My name is Jeremy Kerr. I'm from IBM's Linux Technology Center in Australia. Our team has an open source software development background. We're sort of mostly all Linux hackers at heart, but we all work on open source software, both at work and our spare times. And that's kind of our pedigree. I'm here today to give you some insights about the OpenPOWER Firmware Suite and how you'd go about modifying it and extending it for your own use. That might be to add support for say a new platform, maybe implement a new cool feature, make it work with your own management systems, or as we say in Australia, just for shits and giggles. We have a few documents online about the general process of developing the OpenPOWER firmware. They're a bit scattered. We have sort of blog posts, and we have official documents and unofficial documents and mailing list posts and all these sorts of things. What I'm trying to do here today is give a sort of collected view, an overview of some of the points that warrant going to a bit more detail. So since we're here in person, make use of it. I'm happy to answer questions, or if you want me to clarify anything, please let me know straight away. This presentation has sort of varying levels of technical content. The introduction, we sort of start with some general bits, and it might be a bit obvious to start with, but we'll see how we go. Don't worry, there's only one slide with C code in it, and the rest is a bit of examples in shell. But I guess if you only take one thing away from the talk today is that there is a large community of us working on this stuff, and if you're fiddling with OpenPOWER firmware, you don't need to do it all by yourself. There's a bunch of us who are hopefully accessible to the rest of the world, hopefully accessible to the other developers who are keen, and can help out with your own personal bits of work you want to do on the OpenPOWER firmware. So that said, we'll get into it. I'm sure most folks are familiar already that the OpenPOWER source code, firmware source code, is all up on GitHub. The top level Open-Power project on GitHub kind of hosts a large amount of sub-repositories. So I'll go into a bit of the composition about that soon. And we'll sort of talk about some of these over the time today. Two important sub-projects that we work with is firstly this docs repository, and it contains, unsurprisingly, documentation. As with most documentation, though, there may be some substantial gaps there. There's a fairly large to-do list of things we want to add or clarify, but there is a lot of good stuff there. So I would recommend having a browse through that before you sort of embark on any largest projects. Especially if you're new to OpenPOWER firmware 2, check it out. If you have any feedback on it, let us know as well. The second major component of the OpenPOWER GitHub project is called OP Build, and that kind of brings a bunch of the firmware components together. I'll cover that in a bit more detail soon. As I said, there's a lot of components to a build. Most of the bits that actually make it an OpenPOWER system are contained in OpenPOWER specific repositories. We also pull in a lot of other bits of open source software, utilities, libraries, and some of these components are what ends up getting built into the actual firmware image itself. So we'll have a chunk of separate open source projects which comprise the firmware components in a firmware image. We also need some bits that construct the actual image itself. So like a compiler. Of course you need a compiler to compile stuff. We have some OpenPOWER specific utilities that are used to build firmware images. So that's the second column there. But because we have a bunch of stuff, it'd be really mean to ask everyone to sort of pull those things together manually themselves and build your own firmware. So we have an overall repository called OP Build, and that's our build system. It's based on the builder utility, if you may have heard of it. And this is the top level repo that you would clone to construct a new firmware image. So it handles the download, configuration, compilation, and packaging of all these bits on the left, using the bits in the middle to construct you a firmware image. And in most cases, that's the thing that we flash into the processor NOR, the PNOR on these machines. the given the way that we use the OP build project is it itself is in version control. So in theory, that means that if you have a specific version of the OP build Git tree, we can use that reported version number to find out exactly which components were used to construct that build. So we might say we're using Pettyboot version 1.4.2 plus Skiboot version 5.6 plus this version of the linker and this version of the PNOR image tool. So that top level project allows us to verify and record which sub projects all went into it. So it kind of gives us a bit of auditability and a bit of verifiability. However, that working properly depends on a few things to be set up correctly. So I'll cover that in a little bit. Like I said, we've got a whole bunch of stuff in OpenPOWER Firmware. This slide is a bit of a diagram of a very simplified diagram of how that all works. So as I said, simplified quite a bit. In general, this is sort of the early boot process with time going from left to right. So first up, this isn't my area. So Stuart Smith earlier today gave an excellent talk about the details of this. So this is quite generalized. We start on the left, doing some very low-level machine init. That's the sort of stuff that makes your computer actually act like a computer. At the start, all we have is a little bit of cache and very limited ability to actually run instructions. So that bit on the left turns it into a computer, gets memory up, gets it running out of memory, gets some I/O up, and that sort of thing. Once that's happened, the last thing that hostboot does is launches another piece of firmware called Skiboot. And I often get asked what the difference between hostboot and Skiboot is and why they're two separate projects. And there's a lot of different sort of complexity around that, but mainly think of it as hostboot does the actual low-level initialization, and Skiboot performs a bit of a runtime services for the actual operating system that ends up running. In this diagram, the stuff that's in blue is shipped in the machine firmware, and the stuff in purple, a different sort of shade of blue, is what is provided by the end user. So they'll install an operating system, and that's the purple section there. So blue bits come with the machine, purple bits come from the user. So my focus is kind of these bits here and how Linux and the firmware interact. I can certainly help out a bit with the machine init things, but there's better qualified people here at the conference about that. So Opal, well, we have this piece of firmware called Opal, of which Skiboot is an implementation. Opal stands for OpenPOWER Abstraction Layer, and it provides a way of abstracting all of the quite low-level bits of hardware initialization from the eventual Linux workload at the end. Now, it's possible we could modify Linux to work directly on the hardware with no Opal layer. The Opal layer, or Skiboot here, doesn't provide anything special. It doesn't have any special privileges. Doesn't have any. It doesn't run any protected mode or anything like that. All it's doing is providing a bit of hardware abstraction for Linux, so that it doesn't have to know intimately about the layout of our machines. And in that regard, think of it as more of a library rather than a layer of firmware that's impenetrable. While we're, I guess, discussing this, we need to keep things in context. We kind of care about all these blue bits. This is where we work every day. But for end users, that's the real stuff that they care about. They don't really worry too much about how their firmware works. They just want to get it running, get their workload going, and get their workload going as efficiently as possible. So we kind of need to, when we're doing firmware development, is think about how the global context of how we develop things that enables that to happen rather than getting in the way or requiring weird interactions or that sort of thing. So I'd like to just remind, we everything we do is really to get that purple bit going. Those purple bits are often developed in their own ecosystems. If we make changes to interface that affects that, we need to be cognizant of what consequence those changes have. And it means that the firmware development that we do doesn't make unnecessary demands on those bits of user software. So, like I said, we have different components on the different sources for the stuff running the machine. The stuff that ships to the platform and the stuff that is provided as part of the eventual workload. We sometimes get queries from system integrators who want to develop a fancy new feature and it requires modification to that purple bit. And it's not necessarily a problem, but it requires very careful development. We need to consider the ecosystem, the way people consume those parts, the way that people load those parts onto their system before we can go sort of changing that willy-nilly. For some new features in some systems, that might be unavoidable. Don't think of those bits as completely unmodifiable, but there's always a bit more consideration required when we're doing things that either change those parts or change interfaces to those parts. When we want to modify the firmware, we can do that quite easily, right? We just modify the firmware and make sure that the machine is shipped with that modified firmware. For the external software bits, we need to think about how the end users are expected to consume our changes there. Usually a user will be consuming that through a Linux distribution, so they'll be installing Red Hat, Ubuntu, whatever, and consuming it that way. So if we want to modify it, there's a bit of consideration around that. Do we ask every user to, rather than using Red Hat, use our own custom OS? That's a bit unreasonable. Do we want to have every user have to apply custom patches? Are you going to support those patches forever? So it's much easier to make our changes in firmware than it is to get things through the ecosystem. Not to say that's not possible, but it does, again, require some consideration there. And in doing so, I'd always suggest having a chat with the OpenPOWER community. I've got some resources at the end of the slides about how you would do that, but we need to sort of consider how the ecosystem works and not burden folks too much with OpenPOWER specializations when we're doing that. The method that you'd actually get changes into the Linux kernel on end user systems looks a bit like this. I'm not going to go into too much detail, but any sort of kernel code that we write, we will send upstream to the PowerPC kernel maintainer, who happens to be an IBMer, but that's not necessarily, doesn't have to be the case. He will then do some testing, forward onto Linux, and then at some point in the future, one of the distributions will consume Linus's new tree, and by the time the end user wants to install the operating system, they'll consume it through there. So there's potentially quite a long process there, and it adds a bit of inertia to any changes again that are modifying that purple bit of workload that we had before. Now, why am I mentioning operating system changes in a firmware talk? Because it sort of carries over to other bits of firmware itself. In fact, we have a couple of bits that we need to be a bit careful about modifying. On the right-hand side, the interface between the firmware and the operating system, and in the middle there, we have a bit of, I guess, exposure of firmware into folks' management systems. So we have our bootloader on OpenPOWER machines, and it has folks interface, or people who are provisioning systems will interface that in certain methods to make their data center work. So there's kind of some bits there that we need to consider requirements of customers when we change or remove bits of those or add bits to it. And we've got to think about how they're eventually consumed. So we have I guess, a bit of advice for folks who want to work on these bits. Firstly, work with current standards and implementations wherever possible. We try and make the folks evaluating OpenPOWER, we want to make that as seamless as possible. That means we should make these changes in the context of the entire industry rather than just sort of doing things as a one-off. And discuss things with upstream. If you've got an idea, if you've got a proposed way of doing things, have a chat with the upstream for those projects, and often we can all collaborate to get a good design that's consumable for everyone. Just again, going back to our our sort of boot flow and our components of the system. I want to talk a bit about development now. There's a lot of bits involved. There's a build process that we use to bring it all together. But I think we've done a fairly decent job on making that not too difficult to consume. So for the developers around, this is how we would build a basic flow for building an OpenPOWER firmware image. So firstly, we grab the OP build source tree, and then do a bit of configuration. There's a little shell sort of file that we can source, and that gives us some commands to use the build system, and then we configure and then build it. Now the OP build system will download, like I said before, it will download, build things, and then generate a firmware image suitable for applying to the machine that you've specified in that second last line. That's great if you're wanting to build an existing configuration for an existing machine that's already in the tree. But we're looking at developing here. This is a talk about developing firmware. So we will actually modify some of the components too. Remember that OP build is just the build system itself. It doesn't contain any source code for the firmware. All it's doing is pulling in other bits of firmware and generating this this image out of those bits. So rather than modifying OP build, we want to modify one of the components of firmware. And because Stuart's here, I picked SkiBoot as an example for that, because Stuart's the maintainer for it. This is a simplified process of how we would modify SkiBoot for a new platform, an existing platform. In this case, I've shown Witherspoon. So again, you'd clone the firmware tree. You'd maybe use VI and edit some of your edit one of your platform definitions, and then commit it to the SkiBoot tree. So you should also always commit your changes as soon as you can, so you've got a bit of a record of what you're doing. Now, like many open source projects, we can build SkiBoot with the changes we just made using the make utility. Of course, if you work on your laptop, if you just used the standard compiler you have, you're going to compile SkiBoot for x86, which is not going to work at all. So instead, we want to compile it for the Power architecture, so we use a cross-compiler to do that. Now, on my machine, I'm running Ubuntu. Cross-compiler packages are easily available, so we can just use that. If you don't have a cross-compiler handy, what you can do is actually use the one that's provided during the OP build step. So here what we're doing is we're building SkiBoot, but pointing it to a compiler that's built as part of the OP build system. So that allows us to do like some build checking, to do a compile of SkiBoot, make sure that the changes we've done don't fundamentally break things at the build time. And that gives us a little first pass local build we can do using the OP build cross compiler, and in the previous example, just using the cross compiler we already have here. So SkiBoot is really nice in that regard. It's not too picky about its environment. You can just give it a cross compiler and it'll build it away. Now we actually want to build it into a firmware image, not just a single SkiBoot build. So what we can do is tell OP build, rather than using the sources that are upstream on GitHub, we can point it to our local tree that we've done our changes to. So here, in this case, we're saying we want to use our local SkiBoot tree that has our changes in it, rather than the one that's out on GitHub, rather than the SkiBoot that's out on GitHub. We do that using these SkiBoot site and SkiBoot site method variables, which say use our Git tree, which is in this path, and then use a specific version of that Git tree. So what you do is you make your changes in SkiBoot Git, get the version number that comes out when you commit it, and then feed that version number back into your OP build in this case. So that'll do the normal OP build process. It will use your local changes rather than the upstream SkiBoot code. You can then take the firmware image that spits out and flash onto your machine and test it. And that will now include the changes that you've made into that SkiBoot tree. I mentioned earlier that we can take an OP build version and use that to calculate the versions of all the components that we've used in that OP build run. This kind of ruins that a bit because we've overridden what it thinks are the versions it should use. So this is good for testing. It's terrible for production. You don't want to ship any production images using this sort of thing because now we've overridden something and now our reality doesn't correspond to what's in the actual OP build tree. There's some minor things we can sort of do to mitigate that, but it's really the overriding here is only really appropriate for firmware development. So what's the proper way to do this once you've got your changes right, once you've done your testing, is send things upstream. This is part of that key point of you're never working alone here. You have a community to back you up. Hopefully you could have engaged with us beforehand and said, hey, I'm trying this out. But if you're confident doing things, this could be your first interaction with the OpenPOWER community is to send your patches upstream. If you submit new changes upstream, it removes the need for you to carry those private customizations, and it means that you can use official source trees that also include your support. We hope it's less work overall for you to upstream things rather than keeping them in your private trees. It also means that your changes will get reviews from the community, potentially fix any bugs that might happen in advance, and anything that might happen to other platforms based on your changes are sorted out earlier rather than later. And importantly, this also provides some guarantee that you're complying with the open source licenses in the OpenPOWER firmware. There are certainly other ways to make sure you're compliant, but this is probably the easiest, is to have your code up there. It's available in the same places that people expect, and all of the components that you end up building in your tree, because they're upstream, they're just available as is. Like I said, I'm not a lawyer. I can't tell you how exactly to do this, but it's certainly the easiest method of getting in compliance with the licenses involved here. Any questions about this so far, about the upstreaming? Cool. We often hear that upstreaming can be a bit overwhelming. Certainly with some of the vendors that I've working with, they sort of see it as a big job that isn't necessary, and we can just defer that till later. I want to sort of address that a bit. There's how do we do it? It's fairly simple. These steps are kind of the essence of how you would take your patch that you submitted, or your commit that you committed to ski boot, and submit it upstream. This is a little bit of a simplification, but if you're not familiar, here's a quick example for the ski boot component. The actual process might vary depending on which component of firmware you're modifying, and how the community for that component works. But still, for ski boot, it's fairly straightforward. We use the git format patch tool to turn the commit that you've just made into an email. We can then edit the email, and then we can send the email. So kind of 3 steps there. In this example, we're sending the mail that contains your change to this ski boot email address. Most of the ski boot discussions happen on this mailing list. You don't necessarily have to be a member to send things to it, but I'd encourage it because it means you're sort of participating in the community in advance. When you send the mail, it'll go to the ski boot mailing list. A bunch of us will receive it. I think it's probably about 4 people in this room who will receive the mail that you just sent. And if it's, well, I guess most importantly, Stuart will receive the email. If the code's of good enough quality, he will apply it. If it's not a huge deal. That's fine. It's a collaborative process. You'll get some feedback. You'll get some friendly feedback. If you don't, we'll fix that. I really want to encourage, for first-time contributors, this can be a little bit daunting. Sending the code that you've done that you might not be familiar with, sending it out to the world can be a bit daunting. I guess I'd like to provide a little encouragement and reassurance about that. Stuart's a friendly guy. We try and make the community a friendly, collaborative place for all kinds of contributors, for new ones, for old ones, So regardless of the method you use to submit it, submit your pull request or send an email, really encourage you to give it a go. And once Stuart has accepted your patches, which eventually will happen, you get to remove these bits out of your build step. And you go back to just using OP build to build your firmware, which means you're back to having verifiable version numbers. You have vanilla source trees. You don't have weird customizations. Everything's been reviewed. And you now do a plain OP build, and it has your changes in it, which is really important. Like I said, I have simplified the process a bit, but not a whole lot. Main thing is to encourage you, if you want to go further into how that's done, let us know, or just try it out, see what happens. There's some good documentation on the Git process, especially for developing things for the kernel. If you find some docs for the kernel, it applies the same to skiboot, except don't send it to the kernel mail. Send it to skiboot too. So that's kind of the general build sort of process. I'd like to use a bit more of a solid example in doing a platform port for OpenPOWER. And that has a few important components here. Firstly is an identifier. We've got to call it something. I'll go into why in the next slide, but we've got to think up a name that we can apply to this platform so that when we're running on that platform, we know what it is. We also have some machine definition for that early initialization procedure. I'm going to completely bypass that because it's not sort of an area I work in. There's probably, like I said, better people to help out with that. And we also have an OPAL platform definition for the platform. That's the bit we can sort of go into a bit of detail again. Like I said, the identifier is really important. We call it a compatible string because it's a property within the device tree, which is a machine description, that is used as the canonical machine identifier, and it's usually in a format of vendor, name. So this is the one we use for Witherspoon, the AC922, and it has to be unique. This compatible string is our very last resort for any releases, any fixes that need to happen sort of post-release, and it allows us to apply a fix onto one machine, but not the entire OpenPOWER world. And that'll often be when one of us is engaged to debug something, that'll be the first thing we check to make sure that we're actually working on the machine we think we are, and we're working on the code that we think we're working on when we're doing a debugging effort. So this is really important. We've had cases where folks with other system integrators have taken the reference design and pretty much used it as is, but made a few small modifications, but then not modified the vendor common name string. And it means we're then left with a case where we can't do any sort of late fixes or any fixes on official upstream firmware because we have no way to differentiate the two variations of string of machine. So that's really important. This probably isn't enough information to go on for doing that, but I just want to emphasize that it's really important. Have a chat with us if you have any problems about that. Once that's done, what we need to do is create a definition in OPAL/skiboot that describes your machine. We have a few here already. This is just one of the directories in the skiboot tree. We have a bunch of platform definitions, in this case for the AST/BMC type platforms, which are most of the OpenPOWER ones, or all. And each of those files generally have one platform definition per file. This is a subset of those, that encapsulates platform-specific functionality. When skiboot starts, what we do is we get that compatible string, which I spoke about before, and then, well, actually what we do is we call a probe function in each of the platform definitions. And most of those probe functions will, basically the probe function will turn true if it is that platform or false otherwise. And this is why it's important to have that that compatible string as something unique, because we use that to determine which machine OPAL is starting on. So we'll check that and then say, yes, this is the platform we're starting, and apply all the platform-specific stuff. I've covered about 5,000 bits of functionality in one slide. Are there any questions about that, or what the platform definition in skiboot does? Cool. Okay. Again, after a beer, if you guys like. The next thing to do, you've probably copied one of the existing platform definitions. First thing you've done is change the compatible string, so you've got a unique machine identifier, and then you've implemented your own stuff, your early platform initialization, some of the other parameters that you would have in a ski boot definition for your platform. What do you do next? You want to test it. The way you do that will really depend on how your platform works. So there's different methods of flashing firmware, different bits of hardware functionality that you want to test out. So people often think it's overly difficult to do that. In an effort to solve that problem, Stuart here, I'm mentioning a lot today, I love his work. Stuart here has implemented something called the OP test framework. So that's, as you'd expect, a bunch of tests that do hardware-specific stuff. It pulls in some other test suites and bits of that. And not only does it have tests in it, but it also has some functionality in it that knows how to apply a new piece of firmware onto an arbitrary machine. Hopefully not too arbitrary. But a lot of the intelligence about flashing OpenPOWER machines, about rebooting them, about managing the kind of procedures you want to do in a test are covered in the OP test framework. And that also is on GitHub. It's just another a project on GitHub that you can clone, run your machine, and use it in various environments for testing. So I just wanted to mention that in our coverage today. Compile, definitely test. Of course, in the early stages of development, you want to do just some individual tests. That's fine, but the OP test framework certainly makes a lot of that much easier and more abstracted, I guess. Like I said, there's going to be a few resources here. I want to point you at a few. The OpenPOWER per project GitHub pages are often the best place to start. That's where the sources are held. Each one will probably have a README file about some backgrounds on contributing, on maybe some overall designs. That's probably where I'd start if I was looking at contributing to a new OpenPOWER firmware project. There's also a bunch of per project mailing lists. For those of us who are from ancient times and prefer to use mailing lists, this is where we'd go. And that's divided up by actual source project. Now that's not always helpful if you kind of don't know where to start. We have folks asking, this is great having these specific lists, but I don't know if I want to work on ski boot or if I need to work on Linux or Pettiboot or something else. So in that regard, we have some generic stuff that can be handy. So we have this mailing list. It's pretty low traffic at the moment, called OpenPOWER-Firmware. And that's just a general a collection of folks from different parts of the firmware community who kind of lurk on that just to help folks out who may not have a particular project in mind or don't know which projects are applicable. That's a good place to send mail to if you want to get cracking on that. We also have the Stack Overflow community. We have a few tags there. If you use the OpenPOWER tag, it means that it appears in the list that I check almost daily, and most of my colleagues will also see it at some point. So that's a good place to start too, if you like using new and cool sort of stuff rather than mailing lists. And also, you can ask me. I may be in Amsterdam at the time, so I can't also guarantee a quick response. But most of us in the community who work on different bits are quite happy to answer random questions there. I can't provide 5 nines support or anything like that, but we're all sort of community members here who are very happy to help out. If you can find Stuart's mailing list as well, that could be useful. But I won't put him in a hole here. Cool. Another resource, sort of more on the official side, if you are looking for a bit more kind of guaranteed response, is the OpenPOWER Foundation, of course. For the bits that I've been talking about here today, the system software workgroup is probably the most appropriate. We kind of discussed, surprisingly, system software, and where most of the folks here are members. If you're not, the sign-up process is quite simple. You can be an individual member or a corporate member. But we have this system software workgroup with meetings in different time zones to suit sort of where you are. So we have one early one week, late one the next. And we're trying to sort of group some of the maintenance of these open source projects into the workgroup as well. Not to remove it from the community, but just to have a bit of a regular sort of thing that happens there. Yeah, so that's the kind of set of 3 different resources for where you're at. I'd highly recommend checking them out. Any questions, folks? Thank you.